Hi, the topic is quicksort. Quicksort is a sorting algorithm and it is based on the concept of divide and conquer method. Here, the divide and conquer method is nothing but divides the problem into the subproblems. Each of the subproblem can be solved separately and finally it can be combined together. And the other name for the quicksort is partition exchange sort. Now we will see how a partition is carried out or how a quicksort works. So for that we are following a three steps. So consider an array consists of set of elements. In that set of elements, we have to choose one element as a pivot element and which divides the array into two halves. And then the elements in the left half are smaller than the pivot. The elements in the right half are larger than the pivot. Now this is the conditions. So in center, the pivot value will be the pivot, and in the left hand side of the pivot is smaller values and the right hand side of the pivot is larger values. So this is the subproblem 1 and this is the subproblem 2, and each of the subproblem will be solved separately. Finally it can be combined together. The quicksort creates two empty arrays to hold elements less than the pivot value and the elements greater than the pivot value, and recursively sort the subarrays. There are two basic operations in the algorithm. One is swapping item in place and partitioning a section of the array. So in the next slide, so how we are going to carry out the swapping items with the conditions. So the conditions of a quicksort we will see now. So for that, from the set of elements in the array, we have to choose one element as a pivot. The pivot element can be the first element or the middle element or the last element. It is our choice. Once the pivot element is selected, then we have to go for the comparisons. So for making a comparison, we are taking two pointers. The two pointers are I and j. So I will be located in the left hand side and the j will be located at the right hand side. So I pointer will move from left to right and the j pointer will move from right to left. So first the element will be compared with the pivot. So array of elements will be compared with the pivot in the left hand side. So while making a comparisons, when suppose the array of elements starts from the second element, as we selected first element as a pivot, so the second element of the array will be compared with the first element in the left hand side. So while we make a comparisons, suppose if the element is smaller than the pivot, then the I will be incremented. Suppose if the element in the array is greater, so the I will not be incremented and it will be stopped and it will store the value of I to make the next comparisons. So likewise we will apply it for the pointer j which is located in the right hand side. So in the right hand side the element will be compared with the pivot. Here we will be comparing for the largest value. Suppose if the elements are larger than the pivot, then the j will be incremented, that is it is subtracted by 1. So likewise it continues until the element will become smaller. So once the value becomes smaller in the right hand side, then the j will not be decremented or it will not move further, it will be stopped. Now I and j position values are identified and then we make a comparisons whether I value is lesser than the position of I value is lesser than j. If it is lesser, then the value will be swapped, that is interchange between the elements are interchanged between a of I and a of j. So likewise, suppose if I value is greater than j, then the values will be interchanged with pivot and a of j. So this is in this case only we are identifying the two halves or the two subarrays. Pivot will be in the middle and the left half will be the smaller elements and the right half will be the larger elements. So when we will face this, left half will be smaller and the right half will be larger, means suppose if I value is greater than, the position of I value is greater than the position of j, the position of j value. If it is greater, the swap will be, or the interchange will be taken place between the pivot in the A of j. So now we will see all these steps in an example. Now consider the unsorted array. So now the given we have taken 9 elements and the 9 elements are not in sorting order. So we have to sort it out, that is in ascending order. For that the algorithm we have chosen is the quick sort. So from this set of elements in an array, we have to choose the first element as a pivot. Now 65 is the pivot. Now the 65, which is located in the first position as pivot. 65 is our pivot, and then there are two pointers, one is I and another one is J. So I starts from the second position and J starts from the last item, starts from the last item of an array. So I always move from left to right, J always move from right to left. So we have to check the element left to right with the pivot for the I pointer, and we have to check the element from right to left with the pivot for the J pointer. Now, so the second element 70 is compared with 65. So as we have selected 65 as a pivot, so now always I move from left to right. Now the I position is taken from the second element. So the second element is compared with the first element. 70 is compared with 65. It is greater. So only if it is smaller, the I will move forward. Now it is greater. So now the I value is not incremented, or it's not moving forward because the value is larger. So it is stopped here. Now the I value is 2. And now again now we will be applying for the right hand side. So the J pointer is at the last item. Now the J will be compared with the pivot. Now the J value is 45. So now it will verify 45 is greater than or equal to 65. The condition is false. So now I value is 2 and J value is 9. So both the values of the elements of I and J. So the elements of I and J 70 and 45 are interchange. How it interchange means it verifies the condition whether I value is smaller than J. Yes, I value is in the position 2 and J value is in the position 9. 2 is less than 9, condition is true. So if the I value is lesser than J means, then we have to swap the element of A of I and A of J. That is A of 2 and A of 9. 70 and 45 are interchange now. So once the values are interchanged, again we have to apply it with the next position of I. So the next position of I is now 75. So 75 will be compared with pivot value. So here the pivot is 65 and the I value is 75. Now both are compared. When we make a comparisons, again here it is not smaller. The element of array I is not smaller, so hence it is greater. So always the greater value should be moved to the right and the smaller value should be moved to the left. That's why we are verifying this condition. Now 75 is greater than the pivot value. Now I is not moving forward, it is stopped here. Now I value is 3. The I values, the position of I value is 3. Now we will be applying to the right hand side for the pointer J. Now the J pointer is in the position 8 and the value in the 8th position is 50. 50 is compared with the pivot 65. So it will verify greater value, because always the left hand side verifies the smaller values and the right hand side will verify the larger values. Now it will verify whether the 50 is larger than 65. No, the 50 is not larger than 65. So again the j is not decremented, that is it is not subtracted to move to the left. So now the j value is taken as 8 and the I value is taken as 3. We will verify the condition whether I and I is smaller than j. Yes, I value is 3 and j value is 8. It is smaller, so which means that the swapping must be taken place between a of I and a of j, that is a of 3 and a of 8. And now why we are making the swapping means because smaller value should be in the left hand side and larger value should be on the right hand side. So that's why we are making the interchange. So 75 and 50 are swapped now. This is the second step. So now we will move to the third step. So in the third step, now the I position is moved to the right. Now the position of I is 4 and the position of j is 7. So now again 80 is compared with the pivot. So 80 value is compared with the pivot and the pivot value is 65. So while we make a comparison, 80 is greater than the pivot. So the I is not moving forward and the I value is taken as 4. And now we will be applying the same in the right hand side. Now the j value is now 7. 7 is compared with the pivot. So every time left side also we are making a comparison with the pivot and right hand side pointer is also making a comparison with the pivot. Now 55 j pointer is comparing j pointer, that is j is pointing in the position 7 and the value of the position 7 is 55. 55 is compared with the pivot. 55 is whether greater or not. No, 55 is not greater than 65, which means that j is not decremented, that is j is not moving towards the left. So now the j value is now 7, I value is now 4 and now it verifies the condition whether I value is less than j. Yes, I value is less than j. I is 4 and j value is 7, which is lesser. So in such a case, we have to make a swap between 80 and 55. So as the process is, left hand side always have the smaller values, right hand side always have the greater values. So we make a swap between 80 and 55. So now the third step is over. Now this is the condition. Now in the fourth step, again now the I position is moving forward. So when make a I position moving forward, now the I value is in the position 5 and j values in the position 6. Now I value, so that is element in the I value will be compared with the pivot. So 85 is comparing with the 65, whether it is smaller or greater. No, it is greater. So 85 is greater than 65. So I is not moving forward. That is I is not incremented. It is stopped there and the position is taken as 5. Now j, whether j value, that is j value is now 60. 60 is greater than 65. So it is verifying whether it is greater or not. No, it is not greater. The condition is false. So here also the j is not moving further. It is not moving towards the left. Now I value is taken as 5 and j value is taken as 4. Sorry, I value is taken as 5 and j value is taken as 6 and it verifies the condition whether I is less than j. Yes, 5 is less than 6. So swapping is swapping is taken place, that is interchange is taken place between a of I and a of j. So this is the stage now. So once we make an interchange, now I position is now in 6th position and j is in 6th. Now both pointers values are compared with the pivot. So when we make a comparison, so 85 is greater with the value 65. So the condition is false. So I is not incremented. Likewise, j is compared with the pivot. Here the j value is smaller than the pivot. So here also j is not moving for further towards the left. So now j value is now 5 and the I value is now 6. So now you have to verify the condition. The verify the condition is whether I is less than j or not. So no, here the condition is I is not less than j. The condition I is not less than j because I is in the position 6, j is in the position 5, 6 is not less than 5. The condition is false. So the swapping will not be carried out between a of I and a of j. Instead, the swapping, that is interchange, will be taken place between pivot and the a of j, which means that pivot is 65 and a of j is 60. So both values are interchanged now. So after we make the interchange, we are getting two subarrays now, and the two subarrays are P1 and P2. So now if you see the condition 65, the pivot 65 is in the center, which this is the partition exchange procedure. Now 65 is in the center, the smaller value is in the left hand side and the greater value is in the right hand side. And we got two subarrays now. In the subarray 1 we have the smaller values, in the subarray 2 we have the larger values. So each of the subarray will be solved separately. Again the same procedure we have to follow it. So here again the first element will be taken as a pivot and then it will be compared with I and j pointers. Likewise, subarray 2 will be solved separately. So for this, for example, the left half P1 so will be sorted in such a way 45, 50, 55 and 60. And then likewise the right hand side subarray 85, 80, 75, 70. Here 85 will be taken as a pivot, 80 will be that is the second element will be taken as a I pointer and the last element will be taken as a j pointer. Again the same comparison, a recursive procedure will be applied in a same manner. Again finally the we will be getting the sorted order for the subarrays 70, 75, 80 and 85, and final sorted array, it can be combined together and the combined sorted array is 45, 50, 55, 60, 65, 70, 75, 80. So in this way only sorting taken place in quicksort algorithm. So here when we see the summary of this quicksort, how it works means a given set of elements which is not in sorting order, we have to arrange it in sorting order, that is in ascending order. So for that one element should be chosen as a pivot. So once the element is chosen as a pivot, then we are taking two pointers. One is the pointer is I in the left hand side and the pointer j in the right hand side. Always the I pointers will move from left to right and the j pointer always move from right to left in the right hand side. So every time the left pointer will be that is the I pointer value will be compared with the pivot. If it is smaller, it will be incremented. If it is not smaller, it means the I pointer will not move forward and the I pointer will be stopped there itself, and then we will be proceeding with the j point that is in the right hand side, which is represented as j pointer. There it will verify for the larger values. So it will be compared with the pivot value whether it is larger or not. If it is larger, then it will move to the left. That is the j pointer will be moved to the left. If it is not larger, then the j pointer will not move to the left, it will be stopped there and it will verify the condition whether I value is lesser than j. If I value is lesser than j means the interchange will be taken place between a of I and a of j. Suppose in case if I value is greater than j means there only the partition taken place. The pivot will be moved to the middle. So the pivot will be moved to the middle and the a of j will be moved to the first position as pivot is in the first position. So thereby we are getting a two subarrays. So subarray 1 and subarray 2, each of the problem will be solved separately with a recursive procedure, and finally we are getting a sorted elements that is in ascending order. Thank you. Thank you.